latent heat. Latent heat is released or absorbed by a body or a thermodynamic system during a constant temperature process. An example is a statement of a matter which is change, meaning a phase transition, such as ice melting or boiling water. That is the example of latent heat. And the term was introduced by 1762 by Scottish chemist Joseph Black.
Changes of state. When a substance melts or boils, it absorbs energy, an endothermic reaction. When a substance condenses to a liquid or freezes to a solid, it releases energy, an exothermic reaction. Example: change of state, solid to liquid, otherwise called melting or fusion. Energy is absorbed. It has a positive latent heat of fusion. Liquid to solid, otherwise called solidification or freezing. Its energy is released. It has a negative latent heat of fusion.
Liquid to gas. It is called vaporization or boiling or just evaporation. The energy is absorbed. It has a positive heat of vaporization.
Gas to liquid, otherwise called condensation or liquefaction. Its energy is released. It has a negative latent heat of vaporization. Solid to gas, otherwise called sublimation. Its energy is absorbed. It has a positive latent heat of sublimation.
Gas to solid. It is called condensation. The energy is released while it has a negative latent heat of sublimation.
The equation for latent heat is Q is equal to M times L. This equation relates the heat Q that must be added or removed for an object of mass M to change phases. The object's individual latent heat is noted by L. The unit of latent heat is joule over kilograms. The latent heat of vaporization is from liquid to gas. The latent heat of fusion is the change from liquid to solid.
While the latent heat of sublimation is the change from solid to gas.
Here are some of the examples. Example number 1. How much heat energy is needed to change 2 kilograms of ice at 0 degrees Celsius to water at 0 degrees Celsius? In order for us to get the answer, we have to first substitute the values, in which 2 kilograms is the mass. And oh, you might get confused. 3.3 times 10 to the power of 5 joules per kilogram is given. Next thing that you're going to do is just simply multiply 2 kilograms to 3.3 times 10 to the power of 5 joules per kilogram. And there you have it! The answer is 6.6 times 10 to the power of 5 joules. One more thing, I suggest you to use scientific calculator so that you won't have a hard time in solving the equation.
Really, nigga?